Welcome everyone to this webinar in which we will be discussing the role of standards in harnessing Luminaire data, and in particular what makes T4i and Bluetooth mesh a perfect couple for IoT data monetization. I'm Szymon Slupik, I'm CTO at Silvair, and I'm also chairing the mesh working group at Bluetooth SIG. So let's get going. The prerequisites for harnessing Luminaire data is, of course, a Luminaire that provides data, and as well as network that is used to harvest this data from Luminaires into a processing facility, which may be a local computer system, or typically today this is a cloud services system which gathers the data from the connected Luminaires. So a Luminaire typically includes several components today. There is a light source, of course, then there is a driver, and there may be one or more sensors, and very often there is a network interface device, which may be a wireless device, and in this case I will be, of course, using Bluetooth Mesh as the preferred technology used to illustrate the concept and the functionalities. Also, I will be discussing how Bluetooth SIG and DIIA, which is the organization behind the DALI standard, work together to enable global interoperability. So, actually, speaking of networking in lighting, we have two networks. One network is the intra-luminaire network. So this is the network that's inside a luminaire. And that network de facto is based on the DALI standard. It's been such for years, and now of course it's all started in Europe, then became very popular in Asia, and now we will see also in this presentation it is really invading the American market. The other network is the network that interconnects luminaires into a lighting system. So we call it the inter-luminaire network, and as I said, Bluetooth Mesh here is the perfect match for the intra-luminaire DALI network. So what are the implementation options that we have? So basically there are three. We can either use a standalone Bluetooth to DALI bridge. We can use a driver which has the Bluetooth function integrated, or we can use a wireless sensor controller which has sensing, application control, and wireless functions built in. And it has one other advantage as well, such that potentially it offers the best wireless performance. Sensors are typically extruded out of the luminaire, and that extrusion also includes the wireless antenna, and therefore that antenna is not shielded by any metal parts that makes a luminaire, and therefore typically provides the best radio performance. So one by one, the bridge. The bridge is this top part of the illustration. So we have the light source, we have the driver, we have a sensor, and both the sensor and the driver are connected over a wired DALI bus to the bridge device. The bridge device includes the application control functions as well as wireless functions and wireless circuit with the antenna. So this is an add-on device, and it can be used with potentially any compatible DALI-based driver or DALI input device. Another option, which is in the middle here, is the option of using a driver with the Bluetooth function that is integrated into the driver. And very often a driver like that offers an auxiliary port which accepts a wired sensor. So if you use the wireless driver, of course you do not need the bridge. And many drivers with wireless function integrated, they also offer ports for connecting sensors. And option number 3 is this one that we like a lot, which is using the standard DALI driver and then using the sensor controller device, which has all the sensing functionality as well as the application control and wireless functions included. And the nice thing about this third option is that this sensor controller may be added later. So there may be a standard Luminaire with the DALI driver inside, which is not a networked smart Luminaire, but it has the option to add this wireless sensor controller later. So a system like that can be upgradable. It can be upgraded to provide this smart functionality at any point in time. Now, speaking of the connected lighting systems, of course, there is this very significant need for interoperability. So people want to have support for multiple drivers, very often from different vendors, because they want to select the best driver that matches their application. They want to have access to a wide selection of sensors for indoor, outdoor, high bay. They want to use different sensing technologies like PIR or microwave or others. Also from the available data, they want to have access to energy consumption, to operational statistics, and also to what is referred to as Luminaire asset data. So the asset data is things like Luminaire name, serial number, even color. And also what would be great is if that system would be upgradable, so kind of plug and play solution. So in a nutshell, what we want for lighting systems, we want what computers got with USB more than 20 years ago. If some of you are old enough to remember before USB, in computers we had all sorts of cables, connectors, special cards. So to connect a printer to a personal computer, you needed a Centronics interface with special socket and then special cable between that interface and the printer. And that interface couldn't be used for anything else. So if I wanted to connect a mouse, I needed a serial interface. And if I needed to connect a keyboard, there was a special keyboard port. They are all gone. So USB unified all of those into a single form factor, which defines the physical type of plugs. It defines the electrical interface, the wires, including how the power is delivered over USB, as well as the application behaviors. So you plug in the USB thumb drive and the system knows that this is a storage device. You plug in the mouse and the system knows that this is a human interface device. So there are three aspects of interoperability: the functionality and discovery, the over-the-wire and over-the-wireless communication protocol, and the physical form factor. And the great news here is that the standards organizations are joining forces. And this recent example of DIIA and Bluetooth SIG working together to define one of the goals of that joint cooperation is to define what is called DALI 2 Bluetooth gateway specification. And that really is a specification that will cover a use case for a D4i Luminaire being equipped with wireless Bluetooth mesh node. And why is it such a great concept? So Many of you already are convinced that DALI is the great system to interconnect components inside a Luminaire. So inside a Luminaire, we may have multiple drivers. They are connected on a DALI bus. And you may have sensors, which are also connected on the DALI bus. And you may have multiple types of sensors, occupancy, ambient light, and perhaps more. And where DALI stops, Bluetooth picks up. So DALI stops at mentioning a type of a DALI node, which is an application controller, but DALI does not define the behavior of this application controller. But this is exactly where Bluetooth picks up. So Bluetooth defines the application controller behavior as well as it defines how these application controllers interact with each other, forming a mesh network. So from the technical perspective, there is a DALI D4i Luminaire. It is equipped with a node that is both a DALI node, and from the DALI network perspective, it is visible as an application controller, as well as it is a Bluetooth Mesh peer node, which appears as one of the nodes of the Bluetooth Mesh network. And Bluetooth defines all the behaviors that are needed for the nodes to discover each other and link with each other and interact with each other and synchronize with each other. So this is, I couldn't imagine a better fit for two technologies. One is wired and defines these sets of behaviors. The other is wireless, picks up exactly where the other stops and extends that to system-wide wireless network behavior. What is also notable for this setup is that one thing traditionally present in such systems was the system controller. And this is not needed in Bluetooth Mesh example because in Bluetooth Mesh the control logic is distributed among all the mesh nodes. So the mesh nodes in Bluetooth, they behave more like ants in a colony or birds flying in a flock formation. So they do not need anyone telling them what to do. They just know what to do and they synchronize with each other to behave properly. Interoperability has always been the cornerstone for DALI systems as well as for Bluetooth systems. So D4i, which is defined by the set of DALI specifications, it also has the matching certification and testing programs which are governed by DIIA, which is Digital Illumination Interface Alliance. And Bluetooth Mesh does the same for the Bluetooth part, and the cooperation which we now have between the two organizations is one part is defining the spec, the other part is specifying how you test, certify and qualify the products. And the goal here is to really streamline this testing procedures so that for vendors who want to bring products to the market, this is really frictionless and provides them very quick path to certification. And of course, everybody is happy. You see the smiling faces of people looking at this cooperation. And here is the quote from Arnold Rupp from Osram saying that establishing a standard Bluetooth mesh interface for D4i intelligent luminaires will enable the deployment of even more advanced commercial lighting systems. Couldn't agree more. The last part, which is needed for full plug and play for lighting systems, is the physical form factor. And here is where exactly this year Zaga comes in with their new Book 20 specification for indoor luminaires. So Zaga defines, based on D4i, the physical form factors for a round or rectangular node. form factor, and the connector. So thanks to Zaga, thanks to DIIA, and thanks to Bluetooth SIG, we now have the full equivalent in lighting to what USB brought to the personal computing world many years ago. And considering the success of USB and considering all the similarities here, it's hard to imagine this will not catch up. So actually, I would say 2020 is the milestone year, the landmark for real interoperability for lighting components and lighting systems. So let's talk about some examples of what types of data may be harvested from lighting systems and how this is done and what use we can make of this data, what is needed. So I will be switching now to my little demo system. So in this system we have the Luminaire, which is mocked up here as two light sources, LED strips powered by a DALI driver, and to this driver we have connected a sensor controller. This is a single connection over the DALI bus, so the sensor controller is powered by the DALI bus, as well as there is bidirectional digital communication going on. And then this sensor controller node also has the radio part. So there is an embedded antenna inside and the microcontroller that controls the behavior of the driver. So they all use Bluetooth mesh for wireless interconnectivity. So those blue Bluetooth signs, they illustrate the existence of Bluetooth mesh network here. So this node over mesh connects to the phone, and the phone may be used to configure and control this Luminaire. And also here I have a wireless dimmer which is also using Bluetooth. So by rotating the knob, you can see I can dim up and down the Luminaire wirelessly. And the same can be done from the phone. So I can dim up and dim down, and that communication goes from the phone over Bluetooth to the Bluetooth node, which then acts as Bluetooth to DALI gateway, and to the driver it presents itself as the application controller, and over the DALI bus it controls this driver. So this is the basic control functionality, which probably is extremely obvious to everyone. One thing that I would like to point is the simplicity of that system. So it's just a standard DALI driver, a 2-wire connection, and a standard Bluetooth to DALI sensor controller device. And then we have the Bluetooth network, which allows this controller node connect directly to the phone application. There is nothing in between. The phone talks directly to this one. And we also don't have this central control box because it's no longer needed. So speaking of data, we have we can connect to this individual device, and it offers, I bring it up to the camera, it offers the total lifetime power consumption value, and it also provides other parameters like power. It may also provide voltage or current and other types of data. But of course, while this is cute for demo and test purposes, nobody will be walking with their phones and connecting to individual luminaires to collect energy data or other types of data. So how can we make use of this data? So let's switch to another part of the system, which is the web interface. And this is a standard web browser connecting to the cloud system, which harvests the data from the connected lighting systems. And it can do a number of things. It can display energy use and occupancy in the building. As you can see, it works using the concept of floor plan. And on this particular screen, we can see power consumption or energy consumption by the system. And probably what draws your attention here is that everything is green, bluish, yellowish colors, and there is one spot which is dark red. And the reason why this is green and blue is that this system has consumed not very much energy. This is because of the current lockdown situation where people do not frequently visit the offices, they work remotely, so the systems in the office are mostly dimmed down or turn off automatically, so the energy consumption is very low. However, here in this restroom zone, it appears there was a broken sensor, and that sensor was triggering false occupancy triggers, keeping the luminaire up. And that little luminaire in the restroom consumed much more energy than luminaires in other zones. So this is clearly visible. So what we can see from the screen is that we not only see the pattern of how much energy was consumed when, but also we can identify the suspicious activity like hotspots created by a broken sensor. So this is clearly visible, and without that type of visualization, it would be very difficult, and probably that would go unnoticed for a very long time. Because if if a restroom does not have a window, then probably nobody within the building or even outside can see that the lights are on all the time and they consume energy unnecessarily. So we have two functionalities here. One is the real energy reporting, and you can draw a number of conclusions from that. We can also very easily pinpoint the problematic situations like this broken sensor and replace that, and then check whether it keeps dimming the lights down after it has been fixed. So other types of data that are possible and other scenarios that are possible, I can talk about a couple of examples here, going beyond D4I, but still staying within the realm of what is possible between devices that are based on DALI specifications. So DALI part 202 defines so-called self-contained emergency lighting, and it provides settings for emergency operation modes, functional tests, and duration tests. And thanks to that, using the same infrastructure, wireless infrastructure, using phone to set the system up, and then using the network to collect the data, we can run automatic tests, we can schedule the tests, we can retrieve the test results in a variety of ways, and we can basically operate this whole testing procedure of the emergency subsystem remotely. Actually, this is not only a huge cost saver, it also brings up the quality of service of emergency system up a lot, because any fault, it is detected immediately. It doesn't need to wait until the next inspection comes in, which are of course regular, but of course doing them remotely, it's like the system is under constant observation. So this is one of very favorite beyond the foray use cases where it's not the value of the luminaires itself, it's the value of the connected data that really defines the value of the overall system. Another example, again from the field, is a fully intelligent, I would even say IoT luminaire. This is courtesy of Zumtobel. It's a free floor standing luminaire which has uplight and downlight light sources, and actually the downlights, they cover 2 adjacent desks. So it includes 2 motion sensors, it includes a brightness sensor, of course it has Bluetooth mesh interface, it also includes other sensors like temperature, humidity, air quality, which includes carbon dioxide and organic compound concentration, as well as it may include even a noise sensor. Why is it important? It is important because the luminaire now becomes a sensor hub. So it delivers a continuous stream of sensor information to the network and to applications that make use of that. So you can monitor the environmental quality, you can monitor for some abnormal environmental conditions and act upon it. So again, this is, as you can imagine, in a luminaire like that, the value of data is way higher than the value of just this thing providing a source of light. So as of now, we mostly circled around data related to lighting, directly or indirectly, like sensing data. So we talked about energy monitoring, product maintenance, occupancy, space utilization. These are very popular use cases. This data, of course, may be fed to other systems like climate control systems or access control or other building management systems. What we haven't touched upon, and what's clearly possible when the luminaires are interconnected and form a network, is that they may act as location beacons. So a system like that may start offering location services, it may start be used as the system for asset tracking. Last but not least, this lighting mesh network can also act as a carrier for other devices and systems. One example here is there is a requirement. If you have fire extinguishers in a building, they need to be checked again periodically if they have sufficient pressure inside, because they age, and at some point the pressure falls below a threshold and the extinguisher becomes unusable. And what is being experimented with now is that the fire extinguishers, they have embedded pressure sensors, and these pressure sensors, they send out, using Bluetooth, the pressure information out to the air. And then, of course, the question is, how do you collect that information from fire extinguishers located across the building? And of course, if your lighting system is based on Bluetooth, those Bluetooth luminaires can receive signals from sensors embedded in fire extinguishers and then provide the data to the monitoring application that monitors the fire subsystem. So this is yet another example of how those systems can interoperate together as long as they are based on the common standard. The business opportunity. What is really great about data is that it is not a one-time value. It's a value that is recurring. So the occupancy or energy or air quality or whatever sensing information, it brings value all the time. So this is clearly a recurring value that keeps going over time. And what's even more important, that because all of those systems are software upgradable, you can start with a single service, single type of data, and then introduce more services, more types of data later. And then they will be just adding the value. So in the end, the database-based services, they clearly dwarf the value of the lighting hardware or the lighting system itself. And what is important to unlock the value of the data is to first enable data harvesting by networking the lighting systems, enable data collection network, and make sure this is upgradable. And this in-field upgradability, either via the Zaga, DALI, Bluetooth plug-and-play solution or through software upgrades, is really important, because as time goes by, the number of services and number of solutions and number of ideas that are serviced by those systems will definitely grow. So what we start with today does not need to have to be what we end up with. We will end up with a system that is much more rich than what we can have today. I also mentioned to highlight the recent expansion of DALI, D4I, and Zaga across the Atlantic to North America. So, you know, in North America for years, the market was using analog dimming control based on the 0 to 10 volt control line. Of course, that system couldn't harvest data from the Luminaire. What we have now, we have very clear indication that this concept of digital intra-Luminaire bus based on DALI and D4I and Zaga is really getting traction. So this is very recent information. One of the examples, the US Department of Energy started the challenge for IoT upgradable lighting systems. So this is happening as we speak. So it all started summer 2020, and now in September we are in phase 1, which is the performance requirements and agreements with the manufacturers who will be providing the subsystems. And then this whole challenge is scheduled to end sometime later in 21, where the goal is to provide the luminaires and the sensor controllers from different vendors to demonstrate the plug-and-play interoperability between those systems. It's a really, really, really awesome idea, and I'm extremely happy that this idea is being so strongly picked up across the Atlantic in North America. That really bodes well for these standards to become truly global. So with that, I would like to thank you very much for listening, and see you at one of the future webinars or in person. Thank you very much.